Hi, I'm Anna Petrov from Polaris Quantum Biotech, and I'm going to walk you through submitting a job to the Quantum-Aided Drug Design platform. QuaDD allows researchers to use quantum computing to produce libraries of candidate molecules that complement the features of your binding pocket. Because we use a quantum computer, we can search bigger chemical spaces and find better candidate molecules in just a couple days. Let's get started. Here we have the QuaDD dashboard. To start a new job, click this button. You'll see your username and project name in these gray fields. The first thing that you'll need to do is to add a run description. I usually describe my job with a combination of descriptors, such as the protein name, the ligand name, and the date. For this demo, we'll use the protein NNMT, and I'll name this run description NNMT ligand 1. The next thing that we need to do is to select the protein ligand PDB for the project. You can do that by pressing Choose File, and then selecting your PDB. This one is a good example because it's a complete structure of the protein binding pocket with a reference ligand present. Then I'll click Upload here. At this point, the program is searching the PDB for ligands. If any missing hydrogens are detected, they will be automatically added, but using a PDB that already has been cleaned and protonated is recommended. The next thing that you'll need to do is to choose your ligand of interest from the drop-down menu. So here it says Choose Molecule to Fragment. The ligand names are built from the residue name, chain ID, and the residue ID as indicated in the PDB that you submitted. So for NNMT, I know that my ligand name is FOPA301. On this screen, we see the username, the project name, run description, protein ligand PDB that you selected, and the file molecules. So these include all of the ligands that appeared in your PDB. If you found that you chose the wrong one, so you know that you've chosen the wrong one if over here in this window you see a ligand that isn't the one that you want to fragment, you can choose a different one by selecting it here. You'll also see objectives listed. These features allow you to direct the final candidate library to meet your project goals. Standard returns candidate fragments that have a balance between diversity and similarity. Best in class returns candidate fragments based on the starting ligand. It's a great option for exploring similar binding modes while still having good diversity. First in class returns candidate fragments based on the starting ligand as well as the protein pocket itself. It's good for exploring new binding modes. Scaffold hopping will appear here in the future. We'll use the standard mode for this demo. On this side of the screen, we have fragmentation options. These numbers correspond to the bonds indicated in red, which are sessile bonds. You don't have to cut on each bond, and you may want to divide your reference ligand in a way that helps you explore options for certain R groups. So for example, this first one is 39 to 58, and over here we see 39 to 58. So if I click on this button, I know that I'm going to be breaking right here on this sessile bond. For this demo, we'll check the first one, the second one, and the fourth one, and choose Fragment Molecule. At this point, we have desired fragmentation schemes. We can look at each of the R groups, so here's R1, R2, R3, and R4. You want to select a fragmentation scheme that has between 3 and 6 R groups. That's a good starting point. If you get to the screen and you find that you have 7 R groups or 2 R groups, you want to go back to bond selection by clicking here and change which fragmentation scheme you're using, and that'll give you different R groups. So I can go back to show fragments here. We can also look at this in advanced mode by clicking on this button. Advanced mode lets you select an R group and hold it constant. If you have a particular scaffold that you want to preserve or to escape, you can make that selection in this window. I'll switch back to molecule mode, so show molecule mode for this demo. I'll select each of these fragmentation schemes. As I select them, they appear in this window to the left down here. So I'll select all 3, and we can see that all 3 of them appear here. After you review your fragmentation schemes, press Submit. Here you can look at your submission details and fragmentation schemes. It shows you how many runs you're using here. So right here it says submitting 3 runs. If you're happy with your selection, press confirm. If you don't want to submit the job, press the X here. Here's a status message that indicates that the job has been submitted successfully. You can press dismiss and you'll receive an email when submitted.